Hello everyone. Today I would like to talk about the paper Deep Reinforcement Learning Framework to Automate Trading in Quantitative Finance. This is a research paper URL and our group number is 5 and these are my group members. Today I would like to talk about the motivation of the paper. So while deep reinforcement learning DRL shows great potential in quantitative finance, it comes with a significant challenges for quantitative traders. These challenges include a steep learning curve, error-prone programming and time-consuming debugging. Today, we'll explore how the paper addresses these challenges and introduces a solution to streamline the development process for quantitative traders. Now, let's discuss the need for FinRL. The open source framework is specifically designed to address the challenges we just mentioned in DRL development for quantitative trading. FinRL provides a full pipeline that simplifies agent positioning decision where trader feels that where to trade, at what price, and in what quantity. The motivation is to empower traders with the simplicity, applicability, and extensibility guided by key principles. Now, let's explore how FinRel achieves this. Now, the significance. So, the significance of paper is that FinRel, the groundbreaking framework, serves as a tool to overcome the steep learning curve in DRL strategy design. With its simplicity, applicability, and extensibility, FinRel enables traders to implement fine-tuned DRL algorithms with ease. It's not just a theoretical framework, but a practical hands-on tool for traders to enhance their strategies in various financial tasks. Now, finally, let's discuss the broader significance of the work in the advancing automation and quantitative finance. The paper, through uh, through the FinRel framework, enables portfolio scalability and market model independence, marking a significant leap in algorithmic trading. The contribution extends beyond theory to practical applications in various financial tasks, including stock trading, portfolio allocations, crypto trading, and more. This underscores the transformative impact the paper can have on the field of quantitative finance. Now, my friend Revant will take over.
So here I am telling about major proposal that traders face a steep development curve to obtain an agent that automatically to win in the market, like where to trade at what price and at what quantity. So in this paper we tell about the first open source framework FinRL as a full pipeline to help the traders to overcome steep learning curve. So FinRL framework has a three layers: application layer, agent layer, and environment layer. Application layer maps an algorithm into DRL language by stating the state space, action space, and reward function. Next slide. So in agent layer, the FinRL supports the fine-tuned URL algorithms from DRL libraries in plug-and-play manner. So the agent layer contains the libraries like stable baseline, RL, elegant RL. So in environment layer, the FinRL aims to wrap the historical data and the live trading APIs of hundreds of markets into training environment. So here we use the concepts like machine learning, Markov decision process, and the reinforcement learning. A Markov decision process is a framework used in the field of making the decision. So it consists of a set of states, like a set of actions and transition model that defines from one state to other state after taking an action. The key feature of the property is the state only depends on the future state only depends on the current state and the chosen action. So here my friend will continue.
So hi guys, I'm going to discuss about the technical contribution. So in the technical contribution, the first one is theoretical advancements. The paper contributes to the theoretical advancements of deep reinforcement learning, which is DRL in the field of quantitative finance. And it discusses the application of DRL techniques to automate trading strategies, addressing the challenges posed by the noisy and volatile nature of stock trading. And the second one is the algorithmic innovation. The paper discusses a novel framework, FinRL, which integrates a DRL with finance trading. The framework is built upon the OpenAI gym and the stable baselines, and it is designed to automate trading strategies and optimize returns. Here, the author also discussed the incorporation of volatility scaling in DRL algorithms to trade further contracts, taking into the account market volatility. And the third one is the model architecture or the frameworks introduction. Here, the paper, the FinRL framework, which is designed to facilitate the application of DRL is in automated stock trading. The framework leverages state-of-art actor critic based algorithms, including deep deterministic policy gradient, which is DDPG, and some more like a multi-agent DDPG and a twin delayed DDPG. So next slide, please. So the next one is the experimental setup. Here the authors provide details about the experimental setup and employed in this paper. They discuss the use of various open source DRL libraries, including OpenAI Gym and OpenAI baselines, stable baselines, and Google Dopamine, and RL-lib and tensor layer. The paper also discussed the application of DRL techniques to quantitative finance, particularly in context of stock trading. And the last one is a presentation and discussion of results. The paper presents discusses the results of applying FinRL framework to automate trading in quantitative finance. The authors also evaluate the framework on various financial timing series data and demonstrate its effectiveness in optimizing trading strategies and achieving higher returns. They also compare the performance of the FinRL framework with other DRL-based approaches in the context of stock trading. Here, the paper also contributes. The paper contributions have the potential to advance the application of DRL techniques in the automated trading strategies. Thank you. And from here on, my friend Fennel will take over.
So, hello guys, I'm going to talk about the strength and the limitations of the paper. So, let's go with the strength. The DRL algorithms are the powerful in solving the dynamic decision making problems by learning through interactions with an unknown environment and offer two major advantages of portfolio scalability and the market model independence. In the quantitative finance algorithms tradings is essentially making dynamic decisions, namely to decide where to trade and what price and what quantity in highly and the complex financial market. Second is a plug and the play DRL library, as there is the figure in these slides which compare the three DRL librarians. The details of each library are summarized as follow. Stable baseline is a set of improved implementation of DRL algorithms over the OpenAL baseline. FinRL chooses to support the stable baseline, and it has the advantages like user friendly, easy to replicate, refine, and they identify new ideas and the good documentations. Stable baseline is used as a base around which is new ideas can be added and as a tool for comparing a new approach against the existing one. The purpose is that like a simplicity of this tool will also beginners to experiment with more advanced tool set without being buried in the implementation details. RL library is an open source high performance library for a variety of general applications. FinRL chooses to support RL library due to its advantages like high performance parallel DRL training framework, scale training onto large scale distribution servers, and allowing the multi-processing techniques to efficiently train on laptops. RL libraries natively supports TensorFlows, Eagles, and PyTorch, but most of its internals are frameworks. uh, Elegance RL supports like they like lightweight core codes, less than 1,000 lines, less dependable packages on using PyTorch. And simplicity of these code structures usually can be easily customize their own agents. Effectively, performance is the like comparable with RL library, and stable has like a stable baselines. Now I'm going to talk about the limitations. Next slide, please. So as per the first, a major challenge on the design profitable DRL based QT algorithms is a data scarcity. Most Model-based DR can address these challenges by learning a financial market model 11 to speed up the training process. While maximizing the accumulated reward, the worst case can be used as a regularizer. Second is the graph learning achieves promising result in modeling the interrelationship between stock in prediction-based method. Combining the graph learning with DRL is also potential direction. Third is the current DRL-based QT method exists a poor generation ability due to the several distribution shift of the financial market. Like Meta RL and the transferring learning techniques can help to learn robust the trading policies across different financial asset types and market. The fourth one is the explanatory is of the virtual importance of the high risk decision making task such as the QT, where the hierarchical DRL method decomposes the main goal into the sub goals of the lower layer DRL agents. The last one is the extremely risk to train DRL agents by directly interacting with the real market for the QT. Offline DRL, where only historical data are used for training, has the potential to the model of the distribution shift and the risk of the financial market. Now I will hand over to my friend Bhargav. Bhargav, you are mute.
Bhargav, you're on mute.
Sorry for that. I'm gonna explain about technical depth and complexity. So deep reinforcement learning that balances the exploration of uncharted territory and exploration of current is a promising approach. Its DRL algorithms are powerful in solving in dynamic decision-making problems by learning through interaction of unknown environments. So here, many existing works have been applied in DRL in quantitative financing tasks. So first, I'm gonna explain like what is deep reinforcement learning. So reinforcement learning is a type of machine learning algorithms that learns solve a multi-level problem by trial and error. The machine is trained on real-life scenarios to make sequence of decisions. It receives either rewards or penalties for the action it performs. The goal is to maximize the total reward. So by deep reinforcement learning, we means multiple layer of artificial neural networks that are present to replicate the working of human nature. So we have been employed the task for in the domain of finance. So the related work and algorithmic approaches, Moody and Safel uses policy search for stock trading, and Dong et showed DRL's profitability over conventional methods. So these have variety applications ranging from high frequency trading, future contracts, alternative data, and the liquidation strategy analysis. Next slide, please. So the challenges in DRL trading strategy design. So first one, it is very challenging to create a strategy itself for DRL trading. So second thing is debugging the programming can be time consuming and error prone as it takes time to train the neural network and again have to see the results and change the parameters, etc. The development pipeline consists of backtesting, managing trading states, creating trading environment and pre-processing. As said, like this paper, we are the authors have one intention to streamline the processing of back testing, training testing, so that it is an automated flow. So FinRL framework overview. So this is a open source intended for quantitative traders. Quantitative traders means like their main goal is to find out like when to buy or sell the stocks, at what price, at what quantity should they sell it, etc. Customize it has customization across all the agents and environments. Follows train testing pipeline to narrow down the bridge between simulation and the realities. Next slide, please. So this is the model that has been discussed in the paper. So first one, we have, as we can see, we have the environment where it's the reality, like where the stocks and everything will be there. Action is like on the actions which machine or we intend to take on the environment, so that the state of it changes. Action on environment will produces two outcomes like result and state change. So result means either it is profit or loss. Of course, the intention is to gain the maximum profit, and both will be updated to trading agents, which are usually algorithms, which take them as parameters and then fine tune its parameters so that we can get the maximum output as profit. Next slide, please. So functionalities within FinRel. So transforms live trading platforms and historical data into uniform open agent style. So as said previously, the model will be trained on the historical data so that it predicts the output for the live data. So implements the state of art deep learning, deep reinforcement learning algorithms, offers automated backtesting as a means of assessing trading performance, and also it provides the benchmarks for certain scenarios like which are like frequently occurring or usually occurs. So there are like benchmarks set for that things, and ecosystem offered by FinRel. So it enables the application of DRL agents to range of finance, market related into cryptocurrency, portfolio allocation, frequent trading, etc. And also provide assistance through all level of users with open source community and facilitates the live trading. Next slide, please. So user levels and support. Since there are three types of users like newbies, intermediate, and advanced, so it provides every level user its assistance. So for entry level, it provides documents and instruction materials so that newcomer can get acquaintance with it. And for intermediate level, it offers a elegant RL, which is a lightweight, scalable library, which is focused on finance, like he can fine tune some parameters at least. And advanced provides a FinRel Podraker cloud native training solution where he can have full access to it. And additional tools and support, FinRel, like it provides unified data processor and multi-maker environments to improve FinRel through financial data engineering. Thank you.